That was our last page of this module 13. Now we're just going to summarize kind of what we learned about these normal distributions and the continuous normal distribution and the curve and z-scores and all this stuff. A continuous random variable is not limited to distinct values. It is a measurement such as foot length. We cannot display the probability distribution for a continuous random variable with a table or histogram. We use a probability density curve to assign probabilities to intervals of x values. We use the area under the curve to find probabilities. We use a normal probability density curve to model the probability distribution for many variables such as weight, shoe size, foot length, and other human physical characteristics. Normal curves are mathematical models. We will use mu to represent the mean of a normal curve and sigma to represent the standard deviation of a normal curve. We use Greek letters to remind us that the normal curve is not a distribution of real data. It is a mathematical model based on a mathematical equation. We use this mathematical model to represent the perfect bell-shaped distribution. For a normal curve, the empirical rule tells us that there is a 68% chance that observations fall within one standard deviation of the mean, and 95% of them will fall within two standard deviations of the mean, and 99.7% will fall within three standard deviations of the mean. To compare x values from different distributions, we standardize the values by finding a z-score. And this is how we found the z-score, the little formula. Your value that you're given, x minus mu, which is the mean, over standard deviation, which is sigma. A z-score measures how far x is from the mean in standard deviations. In other words, the z-score is the number of standard deviations x is from the mean of the distribution. For example, z equals 1 means the x value is one standard deviation above the mean. Remember, if z is negative, like if it was -1, it would be same thing but below the mean. If we convert the x values into z-scores, the distribution of z-scores is also a normal probability density curve. This curve is called the standard normal distribution. We use an applet with the standard normal curve to find probabilities for any normal distribution. We can also work backwards and find x values for a given probability. We use a different applet to work backwards from probabilities to x values. With this applet, we found x values corresponding to quartiles and percentiles.